this is one of those problems that is super useful in work and everyday life, and a smart way to solve it can really increase your creativity. A square is divided into 4 areas by drawing lines from the midpoints of its sides to one point inside the square. Find the area of the green region, means here. At first glance, it seems that the problem doesn't provide enough information to solve it. We are only given 3 area values for irregular quadrilaterals, and we are looking to find the area of the 4th irregular quadrilaterals, means this one. Hey everyone, welcome to Geomathic. If we look carefully to the problem's statement, we notice an important hint. All the lines drawn to a single point inside the square are connected to the midpoint of the square's sides. This is the important information we have here. So this shape is a square and these points are the midpoints of the square's side. This means that these points divide the side of the square into 2 equal parts. So all of these 8 segments are equal. This one, this, and finally this one. All of these segments, 8 segments, are equal. We all know that calculating the area of an irregular quadrilaterals can be challenging, and without extra information it's almost impossible. Therefore, we need to create new information, which we can do by drawing additional lines. The most logical way is to break the irregular quadrilaterals into triangles. So if we connect these 2 points like this and divide this shape into 2 triangles, the problem is that there is no useful data to continue. But if we connect these 2 points, it works better. Why? Because now they have something in common. The equal sides that are half of the square's side. And I do the same thing for all of them. So this gives us 8 triangles, and the cool thing is the segments that are half of the square's sides are common to all 8 small triangles. This line, this, and till this. All of these 8 triangles have one equal side, which is half of the square's side. The next step is to find the area of each triangle. We know that the area of a triangle is equal to the base times the height divided by 2. So I write that as equals base times height over 2. The height of a triangle depends on which sides we consider as the base. And remember, height is perpendicular to the base. And of course, the height doesn't always have to stay inside the triangle. It can extend to a point outside of it. Therefore, if we consider this line as the base, the height can look like this, which is perpendicular. If we use this line as the base, height reaches approximately here, which is perpendicular to this base. And finally, if we take this line as the base, the height should be this. The cool thing about this line is that it works as the height for these 2 triangles at the same time. Again, this height is for this triangle and this one at the same time. And here is the golden point. The 2 lines that act as the bases of these 2 triangles are equal, and this height works for both of them. If we go back to the triangle's area formula, we can see that with equal bases and equal heights, the area of these 2 triangles are the same. So again, for these 2 triangles, this one and this one, bases are equal and the height is the same. So the area of these two triangles are equal. Now as you can see, the same thing applies to these two triangles and these two triangles. This height is common for these two triangles. This one for these two triangles, and of course this one for these two triangles. It means like these two triangles, these two areas are equal, these two are equal, and these two are equal as well. So I label the equal areas with the same letter. A, B, C, and D. Now it's obvious that the area we are looking for is exactly triangle D plus triangle A. So how do we find it? Very easily. Notice that triangle C plus triangle D equals 16. So I write that C plus D equals 16. And here triangle A plus triangle B equals 8. A plus B equals 8. Now if we put them together, we get A plus B plus C plus D equals 16 plus 8 equals 24. We also know B plus C equals 10 from here. Notice that triangle B plus triangle C equals 10. So we have this measure B plus C equals 10. And now if we move this 10 to other side, we have A plus D equals 24 minus 10, which is equal to 14. So the area of the green region, which is equal to the area of these two triangles, A plus D equals 14. So I write this 14. Please, if you have solved this problem in another way and found the answer, share your method in the comment. Have a good time.